This is video 15.2. In it we'll be dealing with calorimetry and latent heat. The question. An ice cube initially at -5 degrees Celsius is placed into a calorimeter with 200 grams of water that is initially at 18 degrees Celsius. The idea with a calorimeter is that it's a device that's well insulated so there's no heat loss, and there's generally a thermometer to measure temperature changes. We'd like to know if the final temperature in the calorimeter is 4 degrees Celsius, what was the mass of the ice cube? Step 1 is to calculate the heat loss of the water that's initially in the calorimeter. After we do this, we can set this equal to the heat gained by the ice cube, that is, the heat required to increase the ice cube's temperature and melt the ice cube, and this will allow us to solve for the mass of the ice cube. The change in temperature is -14 degrees Celsius as the water goes from 18 to 4 degrees. We have the heat capacity of water and the mass, which is 200 grams or 0.2 kilograms. The heat loss is given by this equation and is equal to -11,700 joules. Next, we calculate the heat gained by the ice cube. The ice cube increases from -5 to 0 degrees, and we have the specific heat of ice, which is different and less than the specific heat of water. And we don't know the mass. So the best we can do is get an expression for the heat gained by the ice cube in terms of the mass. We use this equation, and we get this expression as a result. Now we'll calculate the heat of fusion, or the latent heat, the heat that's required to melt the ice cube. During this time that the ice cube is melting, it stays at 0 degrees. So I've looked up the heat of fusion of water, and the heat required is given simply by this equation, which we can only express in terms of the mass, which we've not yet found. Now we'll calculate the heat gained by the melted ice. We have to treat this separately because the specific heat of water is different than it is of ice. So the melted ice goes from 0 degrees to 4 degrees, which is the final temperature of all the water. We have the heat capacity of water, and we don't yet know the mass. So we find that the heat needed to increase the melted ice to its final temperature is given by this expression. So now we can calculate the total heat gained by the ice cube. This is equal to the heat required to raise the ice cube's temperature to its melting point, to melt the ice cube, and then to increase the temperature of the melted water to 4 degrees. This is equal to a sum of each of the components we found, and it's equal to 360,000 times the mass. Now we can calculate the mass of the ice cube. We do this by assuming that the net heat loss is 0. So we have the heat loss of water and the heat increased by the ice, and we set that equal to 0. And this implies, after we add 11,700 to both sides, that 360,000 times m is equal to 11,700. Which implies if we divide both sides by that factor, that the mass is 0.032 kilograms or 32 grams. And that concludes video 15.2. Check out PhysicsX on the app stores. This revolutionary physics app for smartphones and tablets contains over 100 videos and 500 multiple choice questions designed by education experts. It's been proven to improve scores for intro college physics, AP physics, MCAT physics, and more. Just look for the blue icon.